The Proctor compaction test is a laboratory method of experimentally determining the optimal moisture content at which a given soil type will become most dense and achieve its maximum dry density. The term Proctor is in honor of R. Proctor, who in 1933 showed that the dry density of soil for a given compactive effort depends on the amount of water the soil contains during soil compaction. As a civil engineer, it is important to have the type of soil with the greatest shear strength. A better shear strength would be achieved by compaction. For the standard Proctor test, you will need the following materials: a compaction hammer, a mold assembly, brush, rubber mallet, trowel, wrench, straight edge tool, spray bottle. You will also need a number 4 sieve, a metal fan, a coarse grained soil sample, and 2 tin cans to the moisture content.
To begin with the procedures, you must first record the width of the metal fan as well as the mold assembly pass enough of the prepared soil through the number 4 sieve to yield approximately 6 to 7 pounds of minus number 4 material. Cover the sieve and shake to remove unwanted large artifacts. Place the prepared soil in a larger metal fan and add water accordingly to prepare at least 4 specimens having water content such that they bracket the estimate at optimum water content. A specimen having a water content close to optimum should be prepared first by traditional additions of water and mixing select water content for the rest of the specimen to provide at least 2 specimen well and 2 specimen dry of optimum and water contents, varying by at least 2% to water contents and necessary on the wet and dry side of the optimum to accurately define the dry unit weight compaction curve.
Some soil with very high optimum water content or a relatively flat compaction curve may be required large water content increasement to obtain a well-defined and maximum dry unit weight. Water content increasement should be not exceed 4%. Come back, the specimen layer often compaction is layer should be approximately equal in thickness priority to compaction place the loose soil in the mold and spread into a layer in uniform thickness. Lightly tamp the soil prior to compaction until it is not floppy. Of using either the manual compaction rammer or a 2 inches diameter cylinder following compaction of each of the first 2 layer and soil adjacent to the mold. Wall has not been completed or exceed above the compact surface shall be trimmed. For the 4 inches diameter mold, come back each layer with 25 blows on the peel of soil should be at least half of full. Using the soil with greater moisture, second layer in operation, the manual rammer take care to avoid lifting the guide. Slip during the rammer up strip hold. The guide sleeve steady and within 5 degrees of vertical apply the blow at uniform rate of approximately 25 blows. And complete uniform coverage of the specimen, sir. For the last time, with soil of greater moisture content, repeat the additional of soil to fill the final layer.
Moisture content, repeat the addition of soil To fill the final layer following compaction, the last layer remove the collar and base plate from the molds. A straight edge tool may be used to trim the soil adjacent to the collar to loosen the soil. From the collar before removal to avoid disrupting the soil below the top of the mold. Carefully trim the compacted specimen even with the top of the mold by means of straight edge scrape across the top of the mold. To form a plain surface even when the top of the mold's initial trimming the specimen above the top of the mold with a knife may prevent the soil from tearing below the top of the mold. Fill any holes with the top of surface with unused or trim soil from the specimen. Press in with the fingers again and scrape the straight edge across the top of the bowl. Determine and record the mass of the specimen and hold the nearest gram. Remove the material from the mold and obtain a specimen for water content by using either the whole specimen or a representative portion from the top and bottom. When the entire specimen is used, break it, it up to facilities drying otherwise. Obtain a portion by slicing the compacted specimen actually through the center and removing about 500 grams of material from the cut faces.
500 grams of material from the cut faces. Obtain water content in accordance with test method D2216. This correction may be made to the appropriate field in place density test specimen rather than to the laboratory test specimen. Plot the 100% saturation curve. Calculate the dry unit weight and water content of each compacted specimen. Plot the values and the compaction curve. A smooth curve through the points. Plot the dry unit weight to the nearest 0.1 balance per feet cube and water content to the nearest 0.1 from the compaction curve. Determine the optimum water content and maximum dry unit weight. This the typical result of the standard Proctor test from graph 1. It can be seen that the data points when connected closely resembled a parabolic curve according to thus this finding effectively follows the compaction curve in a category known as spell shape, also known as type of compaction curve. Specifically, it falls under sandy self bell-shaped category. This suggests that the compaction curve of the soil sample follows a parabolic behavior wherein the dry unit weight increases as the moisture content increases until such time that it reaches an optimal moisture content, after which the dry unit weight decreases as the moisture content increases. In our experiment, these two crucial range of values may be retrieved using the parabolic equation as shown in graph 1. First is the acceptable range of moisture content in version from 10.16 to 19.61, as well as the acceptable range of dry unit weight in kilonewton per meter cube from 16.67 to 17.55. From the aforementioned result, here are the conclusion. Compaction is the process of soil disinfection through expulsion of air and rearrangement of soil particles. Apart from moisture content, the other primary factors affecting compaction are soil type and compaction effort. The compaction curve of soil sample exhibit a parabolic trend whose peak possesses the critical point. The soil sample falls under the class of ML for USCS and A- for ASHTO. Some of the most important benefits in engineering properties attributed to soil compaction are increased shear strength and low compressibility, reduction permeability. Some of the geotechnical hazards attributed to improper soil compaction are structural distress and damage, cracking of infrastructure and soil erosion. Some of the most important applications of compaction include the compaction of soil in fields, construction for highway embankment, earth dams, landfill liners, highway base courses and subgrades, and other engineering structures.